In today's video, we're going to be going over kinetic energy. We're going to derive the equation using intuitive everyday scenarios so that you don't have to rely on memorization. Then we're going to go over conceptual questions that you will see on test day. Finally, I'm going to show you a math trick that you can use to solve square root calculations without a calculator on test day. All right, let's get started. Before we get started, if you haven't yet subscribed to my channel, be sure to subscribe, stay up to date with all of my content, hit that notification bell, hit that like button, and also share this video with your friends. I'd really appreciate it. It'll really help the channel grow. All right, so let's start by defining kinetic energy. And one more thing, this is part of a 3-video series. So in the first video, we talked about potential energy. In this video, we're going to talk about kinetic energy. And in the third video, we're going to relate the two energies to one another in the concept of conservation of energy, which is very high yield on the MCAT. So in this video, we're not going to necessarily apply math. We're going to discuss the concepts conceptually. And then in that third video, you'll see a math problem as you will see on the MCAT. But also, like, these conceptual type questions show up on the MCAT all the time. Let's get started by defining kinetic energy. Kinetic energy is the energy of an object due to its motion. So let's derive the equation over here. We're going to use intuitive analogies similar to what we used in the potential energy video. So if you think about a ball rolling down a hill, which one do you think has more potential kinetic energy? The one that's moving faster or slower? Of course, the one that's moving faster has a higher kinetic energy. And so we can put in our first variable over here in the equation, and that is velocity. Notice that kinetic energy and velocity are on different sides of the equal sign, and they're both in the numerator. So that means they're directly proportional to one another with one twist. So it turns out that we need to add a square over here. So velocity squared. And we'll see what the implications of this relationship is in just a bit. All right, the next variable, think about like if a ball is rolling down a hill. If you had a ball that's 10 kilograms versus a ball that's only 2 kilograms, which one do you think is gonna have higher energy? Like, in other words, you can ask yourself, which one would you rather to be hit with? One that's 10 kilograms or 2 kilograms? Of course, the one that's 2 kilograms. And our intuition there is correct. The one with 10 kilograms will have a higher kinetic energy. So this means that mass is directly proportional to kinetic energy. So what this means is that if you increase mass, you also increase the kinetic energy. But there is another twist over here. You need to multiply this side by half. So the full equation of kinetic energy is half mv squared. Now let's take some conceptual questions that you will see on the MCAT. The first conceptual question we have here is, if you double the mass of an object, its kinetic energy will increase/decrease by what factor? So since kinetic energy and mass are on either side of the equation, they have a direct relationship. So if you increase one, the other one increases. And since there's no like square or cube on top of mass, then it's truly just a straightforward direct relationship. So if you multiply one by 2, then you also multiply the other by 2. So in this case, the correct answer is the kinetic energy will increase in a way where you multiply it by 2. This next one is a bit less straightforward. If you have the velocity, so divide by 2, of an object, how will this impact kinetic energy? The reason why this isn't as straightforward as the first one is because of this square in the equation over here on top of velocity. So start off as you would with mass, ignore the square for the beginning. If you divide velocity by 2, then you would also divide kinetic energy by 2. So 1 over 2. But since we have that square over here, we want to square this. Okay, so when you square this, you have 1 times 1 is 1, and then 2 times 2 is 4. So 1 over 4. So what's going to happen if you have the velocity? Well, the kinetic energy will be divided by 4. Finally, if you double velocity of an object, its kinetic energy will be multiplied by 4. And this is how we arrived at that answer. Forget the square sign for a bit. If you double the kinetic energy, then you double what's on this side. So times 2. But because you have the square, you have to square that factor, that 2 number, so you end up with 4. Now, even though we're not going to go over a math question in this video, we're going to leave that for the conservation of energy video. I did want to show you a math trick that you can use on the MCAT, notably a math trick to be able to approximate square root calculations. Because indeed, over here, using this equation, sometimes when you're calculating for velocity, you're going to have to take the square root of a number to be able to arrive at the correct answer. So let's take a look at this math trick. So the idea here is, like, let's say you were trying to calculate velocity and you rearranged it algebraically. So now you have velocity squared equals 69. So you take the square root of 69 to arrive at the velocity answer. Now, We don't know what the square root of 69 is because it's not a perfect square, but what we do know are the nearest two perfect squares. So the square root of 64, we know that that is equal to 8, and the square root of 81 is equal to 9. So this means that the square root of 69 is somewhere between 8 and 9. To quote Drake, it's 8 some. I went with 8.5. That's not an exact answer. If I wanted to be closer, I might consider, like, is 69 closer to 64 or 81? It is indeed closer to 64, so I might go with something less, like 8.3 or 8.2. In either case, for the purposes of the MCAT, you will be correct if you're like a few points off, because the answer choices are typically far apart from one another. All right, that concludes our video for kinetic energy. If you were looking for a specific math problem to go over, we will be going over one in the next video on the conservation of energy, where we tie the concepts of potential energy and kinetic energy together. Very high yield on the MCAT. If you haven't yet subscribed, be sure to like and subscribe.